All right, boys and girls, welcome back to the drive through your classic physics problem here. Let's draw a little diagram over here. We got an inclined plane, okay? We're going to write our car as if it is a box. Okay, so the 3,200 pounds is going directly in the vertical direction, the negative vertical direction, because that's where gravity is going. So this vector, let's see, is 3,200. Now, what happens is, and this angle is 5.5 degrees. What we get here is a system of similar triangles. So there's two different forces created. This weight is displaced. Some of that weight just presses perpendicular to the box. Okay? And so that is going to be the force of the car against the hill. So this is going to be our purple vector. And in green, that's the amount of force that is going to actually slide down the inclined plane. So the opposite of that is how much force we need in order to keep. That's like how much tension we'd have to pull on the rope in order to keep it still. So what we have to remember is that, I'm going to redraw this triangle big. That's 3,200. And let's see. Now let's use our, so if that's 5.5, then that makes this like 84.5. Okay, so that's the 5.5 degree angle right there. All we're doing here is like a series of similar triangles. That's the purple one. That's the green one. Oh, okay, so we can just do this. We don't have to use vectors at all to find, here's our right angle. All right, according to the 5.5, y is adjacent. 3,200 is hypotenuse, so that's going to be cosine. Cosine of 5.5 is y over 3,200. So y is going to be 3,200 times the cosine of 5.5, but we're going to make sure that our calculator is in degrees. Anybody? All right, so y is 2,000. One more time, Carissa. 267.74 pounds. Okay, so that's how much force is pushing against the box. That seems right to me. And then the green one is going to be, well, sine of 5.5. Carissa, do 3,200 times the sine of 5.5. So x is 3,200 times the sine of 5.5. Negative. Are you in radians, Carissa? That means the first answer was wrong. Okay, we're going to switch our calculator over to degrees. All right, so good. Well, that's actually like a good mistake to put on camera, because you guys are going to be amazed how often you do that. If you are taking math and physics at the same time, switching your calculator from radians to degrees is something you're going to do a lot. So this one was actually 3,185.2678. And then the green one was actually 305 0.2678, 2687. Okay? And that is this answer right here. How much force is required to keep it from sliding down the hill? Hope that helps. Boom!